This assignment is when did I give you this assignment? On Wednesday, na? Correct.
The due date was 7th.
7th. Achha, can somebody send me the PDF? I don't have the PDF right now. And wait, let me see. Okay. Okay, fine. I got the question. The following reaction takes place in one step. How will the rate of the above reaction change if the volume of the reaction in vessel is diminished to 1/3 of its original volume? Will there be any change in the order of reaction with reduced volume? This question, right?
Yes.
Okay, fine. So see, what is the first thing they are saying? What is, read that statement, Sarah? The following reaction, it happens in how many steps?
One step.
That means it is what type of reaction? Elementary or complex?
Elementary.
Elementary reaction. Now, the order of elementary reaction is what? How do we write for this? If we have this reaction, which is saying that it is elementary, 2NO2 plus O2 is going to give me, sorry, 2NO, my bad. 2NO plus O2, it is going to give me 2NO2. Now the rate of this reaction will be equal to what? K into the concentration of NO ki power 2 and O2. Yes or no?
Yes.
We did, right? For elementary reactions only, because it is not complex, it is elementary reaction. That is why this will be the rate of reaction. Now, how will the rate of every reaction change if the volume of the reaction vessel is diminished into 1/3? Now, what happens when volume is 1/3? What is going to happen if the volume is 1/3? So R is directly proportional to, this is concentration. Concentration means number of moles upon volume square, number of moles upon volume for O2, right? Now you can see that R is 1 upon V ki power cube, correct? Yes or no? Can you see that? Okay, that means R proportional to 1 upon V cube. So this is V is 1/3. So V by 3, right? V by 3 cube. This will be equal to, R will be 27, right? Because 3 cube will be 27 and a 1 upon V. So you can write it like this. Wait a second. So the initial rate R1 is equal to how much? R1 is equal to 1 upon V cube. Now R2, as you can see, it is equal to how much? We have here 3 upon V whole cube, right? 3 upon V whole cube. So it is becoming 27 times, right? 3 cube, yes or no?
Yes.
3 cube will be 27 times, right? If we 1/3 it. Now this V square is coming from N2 square and V is coming from O2. Next one is, will there be any change in the order of reaction if the with the reduced volume? No. Order of reaction is equal to 2 always. Order of reaction is not going to change. ठीक है, दोनों चीजें समझ में आ गई? Yes or no? Tell me.
Yes.
ठीक है, तो मेन जो आपका दिक्कत था ना, बस ये था, it is elementary. That is why this will be the rate of reaction. And when you get the rate of reaction, then it is easy. Like अगर concentration double हो रहा है, triple हो रहा है, या फिर आपके पास volume जो है वो half हो जा रहा है. And the other question that I asked was, I think, difference between molecularity and order of reaction. वो लिख लिया होगा आपने? Yes or no? No.
There was only one question.
There is only one question. अच्छा, ये
Yes.
सवाल हम लोगों ने नहीं डाला. नहीं, हमने ये दो सवाल दिए थे. खैर, the next question was the difference between order and molecularity. Okay, so I will ask them to put this question once again. Then आपके आज के assignment में I will ask them to put it. Okay, fine. खैर, that was all about the last class. And in today's class, we are going to do we have this integrated rate law equation. Okay, because we have got this after integration, na? So this is integrated rate law equation for zero order reaction. Now the graph between rate and concentration, and concentration of what? Concentration of reactant. Okay, so this is the first graph. Please see. Here I will be putting up concentration. Again, concentration of reactant. Okay, concentration of reactant. And here we will be having rate. Here we will be having rate. Now we know that rate is equal to K only, right? And concentration of A to the power 0. That means it does not depend on the concentration of the reactant. That is why the concentration, if we increase the concentration, then the rate will have no change. So the rate is same if you don't have any concentration of A. If you have some concentration of A, if you increase the concentration of A, but the rate is not going to change, because rate is not dependent on the concentration. Okay, so what does this whole graph tells me? It tells me rate is independent of initial concentration. Okay, right, next. Graph between concentration of reactant and time. Now, for this, we'll use this particular equation. A naught minus A is equal to KT. A naught minus A is equal to KT. Now, we don't have any powers here. So whenever you get an equation for which you have to plot a graph, you will always try to put this equation in the form of y is equal to mx plus c. You have seen this, yes or no? Please tell me. Mariam, Sara, and Wafia. आप लोग ने देखा ये इक्वेशन y is equal to mx plus c. What about Mariam and Wafia? No, Mariam and
Yes,
Wafia.
sir. Yes,
देखा
sir.
है. Okay, fine. Now, this y is what? Y is our concentration of reactant. X is my time. And c is the intercept. Okay, c is the intercept. If I will have something like this, first of all, let me convert this into that form. So y is my concentration of reactant. Okay, y is the concentration of reactant. That means it is A. So we'll have here A. It is equal to, if I put A here, it will be equal to A naught minus KT. Or I can write it like this. A is equal to minus KT plus A naught, right? So minus K, this is your M. T is तो आपके पास क्या है? T is Y. This concentration of A is X and A naught is the slope. Now, so Y is equal to, sorry, उल्टा लिख दिया हमने. So Y, this is X. Now we can plot the graph also. Now we have a negative slope here because of minus K, and we have an intercept which is positive. So the graph will look something like this. This is your time, and this is the concentration of A. So the concentration of A is very high at time 0 when the reaction has not started. As the reaction starts, the concentration of reactant is decreasing. And what is the slope? The rate at which it is decreasing is equal to minus K. Minus means that the concentration is decreasing, and K means how much it is decreasing. So if K is high, that means the reaction will be very fast and the reaction will be decreasing very fastly. Okay. So this intercept here, it tells me about what? It tells me about the initial concentration of the reactant A naught. Please write this down. Let me know when you're done. Done, guys? जल्दी बताइए. Done or
Done.
not done? Done, na?
Yes.
Right, next, some examples of zero order reactions. Okay, right, number 1. Decomposition of gas on solid surface. On solid surface at high pressure. Okay. For example, you have NH3 gas. In platinum solid, we'll get N2 plus 3H2. Okay. Now here, the rate is equal to what? K into the concentration of NH3 to the power 0, zero order reaction. That is why it will be 0. Second is any photochemical reaction. Photochemical. Now see, in this decomposition of gas on solid surface, it is controlled by the pressure. Okay, it is controlled by pressure. Now photochemical reaction, it is controlled by how much UV rays you are putting. So for example, if you have H2 plus Cl2, in the presence of UV rays, it gives me 2HCl. Now here it does not repeat hydrogen and chlorine. If you just put them together, it is not going to react with each other. Now it only depends on the amount of UV light you are giving to this molecules. Okay. And if you give more UV light, the rate will increase. So here also K will be H2 K concentration to the 0 and Cl2 also 0. You can write here nothing. R is equal to K only, but I'm showing that it is zero order reaction. Okay, it is zero order reaction. Done, yes or no? Tell me. Okay, it's done.
Done, sir.
Okay. Right, next. Enzyme catalyzed reaction. So before that, let's write now some questions. Okay. The decomposition of an ammonia. Decomposition of ammonia follows zero order reaction. Calculate the rate of production. Calculate the rate of production of N2 and H2 if the value of rate constant is given as 1.5 into 10 to the power minus 3 moles per liter per second. Okay, so whenever you have seen what it follows zero order reaction, right? It is given what it is following zero order reaction. That means the rate will be equal to K only, right? Rate will be equal to K only. And what is the rate? K is what? 1.5 into 10 to the power minus 3 moles per liter per second. Now this is my rate. Now you write the reaction. What is the reaction? NH3 getting decomposed. That means it is breaking up into its elemental components. So elementals, nitrogen plus hydrogen. Now you will write 2 here and you will write 2, you write 3 here, right? 3H2. Now you will write the rate expression for all of this. So rate is equal to 1 by 2 minus delta NH3 upon delta T, which is equal to delta N2 upon delta T, which is equal to 1 by 3 delta H2 upon delta T, right? So what are the things we have to find? We have to find this part and we have to find this part only. Okay, so we'll equate both of these with R. First of all, number one, rate of production of N2. So for rate of production of N2, what we have to do? We will just equate this and this. So delta N2 upon delta T, it is equal to R, which is equal to 1.5 into 10 to the power minus 3 moles per liter per second. Second case, rate of production of H2. Now we will equate what? देखिए हम क्या इक्वेट कर सकते हैं, हमको फाइंड ये करना है, ठीक है, वी हैव टू फाइंड दिस, बट वी हैव टू इक्वेट दिस होल थिंग विद रेट ना, बिकॉज ये दोनों बराबर है. ओके, सो विल राइट रेट इज इक्वल टू 1/3 into delta H2 upon delta T. Okay, now we have what we have to find, we have to find delta H2 upon delta T कितना होगा. So delta H2 upon delta T will be equal to 3 into rate, which will be equal to 3 into 1.5 into 10 to the power minus 3 moles per liter per second. So this will be equal to 4.5 into 10 to the power minus 3 moles per liter per second. Done, yes or no? Please tell me.
Done, sir. Yes, sir.
Right. Same. Okay. Decomposition of ammonia. Decomposition of ammonia follows zero order reaction. Calculate the rate of formation of N2 and H2 if rate constant is equal to 4 into 10 to the power minus 3 moles per liter per second. बिना पेन चलाए बस आप लोगों को क्या लिखना है, रिएक्शन लिखना है. NH3 is giving me N2 plus H2. बैलेंस कीजिए रिएक्शन को, 2NH3 and this will be what, 3H2. Now tell me guys, rate of production of N2 कितना हो जाएगा विदाउट बिना पेन चलाए. रेट ऑफ प्रोडक्शन ऑफ H2 कितना हो जाएगा, जल्दी बताइए. चैट में लिखिएगा, आप लोग जल्दी लिखिए. लेकिन फॉर द A1. बी के लिए क्या होगा बताइए सारा. बी के लिए व्हाट विल बी द आंसर फॉर बी. करेक्ट. व्हाट अबाउट अदर्स. वाफिया, मरियम, प्लीज ट्राई कीजिए. सी द लास्ट प्रॉब्लम, इट इज वेरी सिमिलर. ठीक है, ऑलमोस्ट एग्जैक्टली सेम. करेक्ट वाफिया. व्हाट विल बी करेक्ट मरियम. करेक्ट करेक्ट करेक्ट. ओके, नाउ प्लीज टेल मी, बिना पेन उठाए चले हो गया, यस और नो? प्लीज टेल मी. मरियम, सारा एंड वाफिया, बिना पेन
Yes,
उठाए
sir.
हो गया, हुआ ना? ठीक है, तो आप लोग का काम क्या है, देखिए इस तरह का हमने एक सवाल कराया. राइट नाउ देयर विल बी सिमिलर क्वेश्चन. सेम आपके एग्जैक्ट क्वेश्चन तो बिल्कुल नहीं मिलेगा शायद, बट थोड़ा सा आपके पास रिएक्शन कुछ और हो जाएगा, लेकिन रहेगा तो जीरो ऑर्डर ही. अब मान लीजिए हम आपसे आपसे ये कहते, फॉर एग्जाम्पल लेट मी से I gave you this question here. The following reaction follows zero order kinetics. What is the reaction? A giving B plus 2C. The rate constant is found to be 3 into 10 to the power minus 3 moles per liter per second. Now you will tell me rate of formation of B is equal to कितना होगा, rate of formation of C कितना हो जाएगा बताइए. Speak and tell me, turn your mic on and tell me, जो भी पहले बोल दिया. Tell me fast. Rate of formation of B will be equal to
3B into 10 to the power minus 3.
3 into 10 to the power minus 3. And for rate of formation of C will be equal to how much?
6
into 10 to the power minus 3 है ना. दोनों में आपके पास मोल्स मोलर पर सेकंड हो जाएगा ना, मोलर पर सेकंड, मोल्स पर लीटर पर सेकंड. ठीक है, Okay. Now see another type of question. This is one type of question. Then they will ask you the rate of formation, rate of deformation, etc. Now please write another question. This is again for the first question, है ना? जिसमें decomposition of NH3 हो रहा है. So we have given the rate constant is equal to 1.5. They're asking calculate the initial concentration. Calculate the initial concentration of reactant if the concentration of reactant becomes 0.075 moles per liter after 10 seconds. Now tell me what is asked. What is asked here? Initial concentration. What is given here? Given here is final concentration, or you can say that current concentration. Concentration after 10 seconds. That means they have also been given time and concentration. Okay, time and concentration it is given. And also you have been given the rate constant. K is equal to 1.5 into 10 to the power minus 3 moles molar per second. Now what is the relation between the initial concentration on all of these values? Tell me. क्या equation है हमारे पास? What is the equation that relates initial concentration, the current concentration, and time and rate constant? क्या equation लिखा था हम लोगों ने, बताइए. For zero order reaction, what is the equation? नहीं याद किसी को? कॉपी में देख के बताइए भाई, लेकिन प्लीज जल्दी बताइए, इतना टाइम नहीं लगना चाहिए. What is the relationship between initial concentration of and final concentration, है ना, जो भी concentration अभी आपका चल रहा है, and time and rate constant? What is the relationship, guys? अरे जल्दी बोलिएगा आप. थैंक यू. आप लोग डांट ही सुनने में रहते हैं बिल्कुल. A नॉट माइनस A is equal to KT. ठीक है. So this is your initial concentration. This is your current concentration, and this is the time, and this is your rate constant. हो जाएगा सवाल? Yes or no? Please tell me. What do we have to find? Initial concentration. So A naught will be equal to KT plus A. हाँ. Ahmed, you got which one? I could not hear you. I could not hear you. बताइए. Speak once again. क्या बोला आपने?
Sir, I got disconnected in middle. Could you just repeat this question?
Question or the answer?
Yes, sir, the answer.
Answer, na? So I am saying that first of all, see what has been asked and then write whatever has been given. And I asked them, what is the relationship between initial concentration and these terms? That means the final concentration, time, and rate constant. How are these all things related? These four things related. So Sarah answered me, sir, there is a equation for the zero order. If we have zero order reaction, then the formula A naught minus A is equal to KT we have learned in the last lecture. Now we have to find out what is A naught. A naught will be equal to, what is K? 1.5 into 10 to the power minus 3 molar per second into time is 10 second. Second and second will cancel each other. And plus we have to do what? Plus the current concentration is 0.075, right? Now just add this things, all of these things. It will be 1.5 into 10 to the power minus 2 plus 0.075, which will be equal to 0.075 15 plus 0.075, which will be equal to how much? 90, na? 0.90 or 090, 0.090, right? Molar. ठीक है, so all of these questions are quite easy. Please write this down. सिंपल सवाल आएंगे जीरो ऑर्डर में, एक दो सवाल और करते हैं हम, फिर आगे बढ़ेंगे. इनिशियल करंट एंड टाइम, ठीक है, रेट कांस्टेंट तो रहेगा ही हमेशा. यू हैव टू कीप ट्रैक ऑफ इनिशियल कंसंट्रेशन, करंट, concentration, time, and rate constant. How are these related? It is related as A naught minus A is equal to KT. A naught minus A is equal to KT. Done? Yes or no? Please tell me fast. Done, guys? No.
Done.
Okay.
One
Finished, na, Ahmed?
minute.
1 minute. Okay. बस इतना लिखना ही है आपको, ये मेन है. I will make slides for questions. सवाल लिखने में बड़ा टाइम चला जाता है.
Okay, sir.
Okay. Write another question. Again, think the decomposition of ammonia. It follows a zero order reaction, है ना? It follows zero order kinetics. Okay. If rate constant of rate constant of zero order, sorry, rate constant of decomposition of ammonia is given as 4 into 10 to the power minus 3 moles per liter per second. Moles per liter per second. They're asking how long will it take? How long will it take to reduce the concentration? To reduce the concentration of NH3 from 0.1 molar to 0.064 molar. ठीक है? Solution. What has been asked? Tell me. What has been asked here? Out of those four things, what has been asked?
Time.
Time. Very good. Time. यानी कि आपके पास क्या क्या चीज होनी चाहिए? लीनियर इक्वेशन इन वन वेरिएबल ही सॉल्व कर पाएंगे आप, ठीक है ना? आप 12th क्लास में आ गए, इसका मतलब नहीं कि लीनियर इक्वेशन आपके पास 2 वेरिएबल में है और एक ही इक्वेशन सॉल्व हो जाएगा. आपके पास एक इक्वेशन है तो एक ही अननोन रहेगा ऑलवेज. ओके, सो डोंट वरी अबाउट इट. यू हैव बीन आस्क्ड टाइम्स, सो यू विल नाउ फेच वेयर इज A, where is A naught, and where is K? Tell me, what is the A? What is A here? What is the current concentration? अभी concentration क्या है NH3 की? What is the current?
0.064 molar.
Yes, correct. It is 0.064 molar. It is not happening into shape. What is A naught? 0.1 molar. What is K? It is 4 into 10 to the power minus 3 moles per liter per second. This is also molar. ठीक है, कर लिए. Tell me what is the time? You have A naught minus A is equal to KT. So time will be equal to A naught minus A divided by K. आंसर बताइए कितना आ रहा है. करेक्ट सारा. व्हाट अबाउट अदर्स? तो सारा का आंसर आया अभी तक. अच्छा अहमद, व्हाट हैपेंड? व्हाई आर यू लेट टुडे?
I was having some troubles with the internet.
Oh, okay. सिर्फ सारा का आंसर आया अभी तक. जल्दी आंसर कीजिए, क्या हो गया? बहुत टाइम लगा रहे हैं आप लोग. नो अहमद, थोड़ा और ट्राई कीजिए. गलती कर रहे हैं कहीं आप. Either it is a typo or you are doing a very silly mistake. Correct. What happened? Wafia and Mariam? Wafia got disconnected. Mariam, क्या हुआ? Yes, Mariam. Is Mariam not here? अच्छा, Mariam भी नहीं है क्या यहाँ पे? Okay. So we have here A naught minus A, which will be equal to 1 minus 0.064 upon 4 into 10 to the power minus 3 molar. And here also you'll have molar, and here you'll have molar per second. So this molar and molar will cancel each other. Get second above. 1 minus 0.064, it will be equal to how much? 0.036 into 10 to the power 3 upon 4, which will be equal to 36 upon 4, which will be equal to 9 seconds. Okay, so questions will be as simple as that. Okay, don't have to worry. And decomposition of ammonia हमने इतनी दफा करा दिया है. आपके पास एक बार CBSE में सवाल आया था directly. They gave this reaction. Decomposition of ammonia on hot platinum surface is dash order reaction. ठीक है, तो उसमें आप लोग को लिखना था zero order reaction. This is the answer guys, जिन लोगों ने नहीं लिखा अभी तक. Why it is not making any? Oh, now it is making. But if I do it here, it will not make. Oh, it also is making. चलिए, right next first order reaction. Right next first order reaction. first order reaction, please write the reaction in which rate depends on the reaction in which rate depends upon the first power of the concentration term of reactant in the rate law expression. So if we have something like A giving me some product P, then in this case, the rate will be equal to the rate constant times the concentration of A, and there will be power 1 here. Okay, so this is what? This is the rate law expression. No, this is the theoretical rate. What is the experimental rate? It is also equal to minus D into the concentration of A upon dt. Okay, so ये क्या आपका experimental है? That means we have to do experiment, then only we can get this particular rate of reaction from this. इससे हमको कैसे मिलेगा? Until unless we don't do experiment, we will not get the rate. But this is can get this rate if we know the rate constant and if we know the initial concentration. Okay. Now what do? We will equate the theoretical and the experimental. So before that, what we can do is we can plot a graph also. अभी आप लोग के लिए ग्राफ प्लॉट करना आसान हो जाएगा. See, R is equal to K into A. We can write this as Y is equal to mx. So Y will be what? Y will be the R, that means the rate, and A will be the constant, X will be the concentration. Now Y is equal to mx plus C. These graphs, they pass through origin. So the shape will be something like this. Okay. They pass through origin. We have here concentration. Okay. That is the concentration of A, the reactant, and here we are having the rate. Fine. So this is the plot. What is the slope here? Slope will be equal to the rate constant K. चलिए. Now write next expression for rate constant. Okay. Can I move on? Yes or no? Please tell me, guys. आगे बढ़े. Can we move on? Yes or no? Please tell me.
Yes, sir.
Okay. Now express the rate constant. If I have these are the two things. R is equal to K into A, R is equal to minus D upon dt. So we'll equate both of these things. What we will be having? We will be having minus D into the concentration of A upon dt. This is the rate that we get after doing the experiment. And if I know the rate constant and the initial concentration of A, then also I can get the rate. So these are the two rates. And now we will do variable separation. Variable separation, what do? We give the dt there. So we'll have minus D into the concentration of A upon the concentration of A is equal to K dt. Now we will integrate both sides. Minus dA upon concentration of A is equal to integration of k dt. Okay. Now 1 upon a, right? This is what? This is 1 upon a. So the integration of 1 upon a is equal to log a. And since we have a minus sign, the minus sign will be as it is here. This k is a constant, so it will come up outside, and integration and differentiation, they will cancel each other, and we'll get kt. We're going to get what? Kt plus there will be a constant. Why a constant will be there? Because we are not integrating with any limits. We are not integrating with any limits. Now, what will be the value of this constant? So we'll get the value of this constant when at t is equal to 0. When t will be equal to 0, then concentration of A will be equal to initial concentration. That we write it as A naught. Okay. So at time 0, if I write this equation, it will be equal to minus log of A naught will be equal to k into 0 plus constant. This will give me the constant as, constant will be what? Minus, now the constant will be minus log of A naught. This will be my constant. ये समझ में आया? सोनो प्लीज टेल मी. ये समझ में आया आप लोगों को? The constant will be minus log of A naught. Yes or no? Please tell me, guys.
Yes, sir.
ठीक है? Last time ही की तरह था. Now what we'll do? We will plug in this value of constant. Plug the value of constant. Okay, on this equation on 1. So what we'll be getting? We'll be getting minus log of k is equal to kt. Constant is minus log of A naught. Okay. Now अब देखिए क्या हो गया? Log of A naught minus log of A will be equal to kt. ठीक है? पुराना क्या था हमारे पास? A naught minus A is equal to kt. अभी क्या लग गया? बस log लग गया है. Log A naught minus log A is equal to kt. आप इसी तरह दोनों को याद रखिए. ठीक है? पेयर में A naught minus A is equal to kt, and now log A naught minus log A is equal to kt. Log A naught minus log A is equal to kt. Now by using identity, we can further simplify this equation, but as of now let us put it like this, and this is what you are going to remember. Okay, log A naught minus log A is equal to kt. Now further you can simplify it. Please write log of A naught upon A using identity is equal to kt. Now this log is what? This log is log of base E. Now in order to remove this base E, you will write 2.303. Now this will be log of base 10, natural log. This will be log of base 10, and we'll have E naught as it is and A as it is, equal to kt. Okay, is equal to kt. Now you're right. K is equal to, K will be equal to how much? 2.303 upon the time log of A naught upon A. Okay, so if you can remember this equation, then it is well and fine, but the least that you have to do is remember the above equation, which is similar to the zero order reaction. Okay, so K is equal to 2.303 upon T log A naught upon A. We will look at the graphs also. Okay, we will look at two plots. Okay, we'll look at two plots. Graph for first order kinetics. Number one is concentration versus time. You can write concentration versus time. Now, what is the equation that we are having? Please remember, we will remember that equation only, that which is log of a naught minus log of a is equal to, it is equal to how much? It is equal to kt, है ना? It is equal to kt. Also, one more thing we can write here is that it is equal to kt upon 2.303, है ना? We are keeping the base as 10. Upon a 2.303 आ जाएगा. अच्छा. Now here what we are going to do again, we will represent this as y is equal to mx plus c. So what is my y? Y is the concentration. Concentration means this part minus log of a. So I will write log of a is equal to y is equal to mx plus c. What is the x here? X is the time. So we will have is equal to kt. This minus will go here. So this will become minus kt upon 2.303 plus, और थोड़ा सा अच्छे से हम इस तरह से लिख देते हैं. You have minus k into, you have time plus c. C will be what? Log of a naught. Okay. So this is your y. This is your m x plus c. Now draw the plot. So in this structure we have our slope is going to be negative, obviously, and my intercept is going to be positive. Okay, so that is why इसको थोड़ा सा और इधर कर देते हैं. Log of a, and here we are having time, and the plot goes something like this. It's very similar. What is the m here? The slope minus k upon 2.303. Okay, and this part here, it is what? It is log of a naught. Now here you will write one more graph. In this graph we are having time, and here we are having ln of a. Ln means not the log of base 10. We have log base e. Now in that case also you are going to have the same plot. The slope will be also like this. There is no change in the slope also, but here, sorry, there is no change in the line how it is directed, but the slope will change here. Will not have the 2.303 here. The slope will be only equal to minus k if it is ln, and this will be what? Ln of a naught. Okay, it will be ln of a naught. So please write both of these side by side. लिख लीजिए. Let me know if you have drawn both the plots. Done. जल्दी दोनों प्लॉट बना लीजिए. Done, yes or no, guys? No, not done. जल्दी जल्दी बनाइए. I will give you few more seconds, and then we will look at next graph. Okay, that is it. Write the next graph, second graph. Now this graph is between log of A naught upon A versus time. Log of A naught upon A versus time. So in the equation we have already seen, see, this is the equation. Log A naught upon A, it is equal to how much? KT. And if you write this 2.303 here, it will be equal to how much? Log of A naught upon A is equal to KT upon 2.303. Okay, so we'll write this. Log of A naught upon A is equal to KT upon 2.303. This is my Y. Whole thing. Okay, this whole thing is Y. This is what? This is mx. Now here t is equal to here, t is the x here. We'll get only one graph. Write the plot. It will pass through the origin. It will pass through the origin like this, and its slope will be kt upon 2.303. Here you have time, and in this axis you have log of A naught divided by A. Okay. Done? Yes or no? Please tell me. जल्दी आप लोग आंसर देना बिल्कुल बंद कर दिए. हो जाए तो जल्दी बताइए. Then we will do one question. Very interesting question. We will do. Done, na? Okay. So see, what are the equations that we have seen right now? We have seen that, first of all, for first order reaction, R is equal to K into the concentration of A. Then what did we saw? We saw something that you will always remember, log of A naught minus log of A is equal to KT. Right? Then the last thing that you have to remember is what? Both of these are what? Log of E. You will remember log A naught upon A is equal to KT upon 2.303. Okay, KT upon 2.303. So these are the equations that you remember. Chali. Now write a question. It's a very important question. It has been asked multiple times in CBSE examination. Prove that the time required for completion of time required for completion of 99% of the reaction. 99% of the reaction is double than the time required for the completion of 90% of the reaction. In first order. Okay. Okay, so first of all, what we'll do, we are going to write the equation. What is the equation? Log of A naught upon A, it is equal to KT upon 2.303. Okay, KT upon 2.303. Now we have to do everything with respect to time. So I will now convert this equation with respect to time. So what is time equal to? So I will write this. Time is equal to 2.303 divided by K log of A naught upon A. Log of A naught upon A. Okay. Now please just write till here, and then after this you please start listening. Okay. Write these two lines only. Log A naught upon A is equal to KT upon 2.303, and here T is equal to what? 2.303 upon K log A naught upon A. Log A naught upon A. Now, let us say if we have initially 100 amounts of A, then if I complete the reaction, then 90%. Hai na? If we have 90% completion, 90% of reaction is complete. That means we will be remaining with how many A? 10A. And if it is 99% complete, then we will be remaining with only 1A. Yes or no? Please tell me. You got this point? This is initial. If I initially have 100A and the reaction is 90% complete, that means 90A has reacted, it has formed R, and 10A is remaining. If I have completed 99% of the reaction, that means 99A has reacted, and we have got only how many are A remaining? Only 1A remaining. You got these points? Yes or no? Please tell me, guys.
Yes.
Mariam, Ahmed, Sarah.
Yes.
Yes. Okay. Now we have to find out. Okay. Now we have to find out T for 90%. This will be equal to what? See what we have here. T is equal to 2.303. Please listen. Don't write. Log. This is what? Base 10. A naught. What is A naught? Please tell me. Initial concentration क्या है बताइए? Tell me guys, what is the initial concentration? क्या लिया है हम लोगों ने? इनिशियल कंसंट्रेशन क्या लिया? जल्दी बताइए. What have we taken the initial concentration as? अहमद, मरियम, सारा, वाफिया, जल्दी बताइए. अरे 100 ना, अभी तो लिया हमने. इनिशियल 100 है अगर तो, राइट? सो 100 जनरल केस 100. What is the final for 90%? 10. वेरी गुड. ओके, अब देखिए ये कैंसिल हो जाएगा 2 से. ठीक है, यस सर नो? 2 से नहीं, सॉरी सॉरी, ये हमने क्या किया? माय बैड. This will get cancelled by 10, right? And you will here. Like this. Now log 10 is equal to 1. So T of 90% will be equal to 2.303 divided by K. Now let us look at T of 99%. Will be equal to 2.303 divided by K. Log of what is A naught? Tell me fast. Initial क्या है हमारे पास? Please tell me what is initial?
100.
Very good. 100 divided by what is the final for 99%? What is the final?
1.
1 है ना? So now 2.303 divided by K. Log of 100 is equal to how much? Log of 100 is equal to how much? Log of 100 is equal to how much? Tell me guys. अरे जल्दी बताइए. Log of 100. हाँ, very good. Log base 10 of 100 यानी कि 10 की पावर कितना? तो 100 मिलेगा. So it is equal to 2. And what is this 2.303 upon K? This is nothing but T 90%, right? So you can write T 99% is equal to 2 times T 90%, and this was the question that they had asked. यही पूछा था उन लोगों ने हमसे, right? So this is how you have to do it. Hence proved. For a first order reaction, T 99% is equal to T 90 is equal to twice or double the time taken for 90% completion. Please write this down. %90 complete. Done, guys? Yes or no? Please tell me.
That's it.
Done. Okay. Chali. So see, that is it for today. So we have completed both the reactions, 0 and first order reactions. Okay. And after this, in the next class, we will be looking at some more problems. And once the problems are done, we will be looking at half-life of these things. Okay. Next topic will be half-life. What is half-life? Half-life means the time taken for 50% completion. अभी हम लोगों ने देखा T 90%. तो ये हम लोग देखेंगे T 50% for zero order, and also for first order. दोनों के लिए T 50% के इसका जो concept है उसको देखेंगे. And after that, we will do some more questions on half-life. Half-life में बहुत interesting questions बनते हैं. So we'll do those questions, and then we will be looking at the effect of C. अभी हम लोगों ने देखिए rate को change करने के लिए the first thing that you can do is you can change the concentration, right? So we did change the concentration, है ना? Concentration change करने से किस तरह से change आ रहा rate में, we saw that. After we are done with this, then we will write things about temperature and catalyst. How do these things they change the rate of reaction. And in order to understand all of these things, we have to understand, first of all, the collision theory. Now, the collision theory. Okay. So most probably we will be done with the 50% and some numericals, and we will touch the collision theory in the next lecture. That will be on